So it turns out our solar system has visitors. And I'm not talking about the usual comets and asteroids from our own cosmic neighborhood. Nope. We're talking about objects from the massive, dark spaces between the stars. And their arrival, well, it's kicked off one of the biggest scientific debates in astronomy today, pitting two very different ways of looking at the universe against each
On one side, you've got the mainstream view, summed up perfectly here by Professor Brian Cox. He looks at the latest visitor, this thing called 3I Atlas, and says, "Look, it's a comet." It's the simplest explanation. It fits what we know. And in science, you know the simplest answer is usually the right one. It's just a natural object on a path we'd expect. Case closed. But then, on the other side, you have Harvard's Professor Avi Loeb. His research is right at the heart of all this, and he kind of frames the debate like this. Some folks comment on the game, but others are actually on the field playing. And he believes the data from these visitors is pointing to something, well, a lot weirder than just another comet. So, you see, this is way more than just an argument over a chunk of space rock. This is a fundamental clash about how we should even do science. How do we approach something totally new? Something that doesn't quite fit in the boxes we've already made. So you have Professor Cox, who represents that consensus view. Let's stick to the natural explanations we know and trust. And then you have Professor Loeb, who's actually published 11 papers on this object, saying, hang on a second, there are at least 10 weird things about this that the simple comet explanation just can't account for. To really get what this argument is about, we need to meet the visitors themselves because 3I Atlas isn't the first one to show up, and each one of these guests has brought its own suitcase full of mysteries. Okay, so first, back in 2017, we had Oumuamua. Remember that one? Super weird cigar-shaped thing that sped up as it left the sun with no comet tail. Total head-scratcher. Then in 2019, 2I Borisovsky came along, and it looked, well, totally normal, just like a comet from around here. But 3I Atlas, our third guest, it's different, and its sheer size is what's causing all the fuss. Yeah, that's right, 3 billion tons. That's the minimum estimated mass for this thing. It's 1 million times more massive than Oumuamua. And for Loeb, this is a huge statistical red flag. I mean, think about it. Why would the third interstellar object we ever find be such an absolute monster? If these were all just random natural pieces of debris, we should have seen 1 million tiny ones before a giant like this showed up. So, to try and figure out what's going on, scientists at Harvard did something really, really clever. They did some cosmic detective work. They took the speeds and directions of these objects and basically hit rewind, tracing their paths backwards through the Milky Way to see where they could have come from. And the key to this whole thing is a concept called vertical excursion. Okay, just think of our galaxy like a flat vinyl record. Most of the young new stars hang out right on that flat plane, but as stars get older, gravity knocks them around a bit, and they start to drift up and down, kind of wandering above and below the record. So, by measuring how much an object wanders, you can actually get a pretty good idea of how old its home star system is. And when you plot these paths, the difference is just wow. Oumuamua's journey is super tight. It barely moves up or down from that galactic plane at all. But the orbit for 3I Atlas, it's this enormous sweeping loop, soaring high above and then diving way below the disk. That one visual difference is a massive clue about where they were born. So, after all that cosmic backtracking, what did they find? Well, it turns out our three visitors are not from the same side of the tracks at all. In fact, they come from completely different cosmic neighborhoods. The analysis of Oumuamua's nice, tight orbit suggests it came from a pretty young star system, probably less than 2 billion years old. It was born right here in the busy, flat part of the galaxy's disk where most stars like our sun live. Okay, now visitor number 2, Borisov. Its path looked a lot like our own sun's, so that suggests it got kicked out of a middle-aged star system roughly the same age as ours. So far, so good, right? These two seem to fit our models pretty well. But then, we get to 3 Atlas. Its huge vertical journey tells a totally different story. It likely came from a much, much older population of stars in what astronomers call the thick disk. It's like an ancient, more spread out halo of stars that surrounds the younger flat part of the galaxy. So, what we're looking at here are three completely different origin stories. Oumuamua is the young one, Borisov is the middle-aged one, and 3 Atlas is the ancient one. The big takeaway here is that interstellar space isn't just filled with one kind of thing. It's a cosmic grab bag with stuff from star systems of all ages, from all over the galaxy. I mean, this discovery is incredible. It opens up a whole new window on the universe. Think about it. These objects are physical samples from other star systems, and they're being delivered right to our front door, free of charge. Which brings us right back to the $1,000 question at the heart of this entire debate. When something like Oumuamua or 3 Atlas shows up and it has properties we just can't easily explain, are we just looking at a new kind of natural object we've never seen before? Or could it be something else? And this is Professor Loeb's whole point. He argues that whether they're natural or not, we are missing a massive opportunity here. Instead of just debating from Earth, we should be sending missions out to actually meet these things. I mean, even if they are just rocks, they are rocks from another star system. Studying them up close, he says, is nothing less than a scientific revolution just waiting to happen. And here's the real kicker. These close encounters, they are not nearly as rare as we thought. Get this. Years before we even saw Oumuamua, a much smaller interstellar object flew into our atmosphere and burned up as a meteor over the ocean. It just took scientists years to go back through the data and confirm that, yep, it came from outside our solar system. And just look at the difference in scale we're talking about. We've got Borisov, which is almost a kilometer wide. Then there's Oumuamua, about the size of a football field. And then you have that 2014 meteor, which was less than half a meter across. They really do come in all shapes and sizes. So, what this all suggests is something called a power law distribution. It's a fancy term for a simple idea we see all over nature. Small things are way, way more common than big things. So, for every one giant object like Borisov that we manage to spot, there are likely thousands, maybe even millions of smaller ones, like that 2014 meteor, just zipping through our solar system, totally undetected. So, the bottom line is this. We are not floating alone in some empty void. Our cosmic backyard is constantly being visited by messengers from other star systems, big and small, young and old. The debate over what they are is definitely going to continue, but the real question isn't if another one will arrive. It's, what are we going to be ready to do when it does?